Hello and welcome to part 2 of 6.4 applications of one variable linear equations. So now we're going to look at word problems. Here's the procedure to solve a word problem. You can pause the video now to read it, refer to the notes, or refer to the textbook. So if we get started, we'll look at problem set 2 with example 1. Okay, so it says that we have a professional house cleaning service that charges a base fee of $20 plus $32.50 per hour to clean this house. If the total bill for cleaning the service was such and such before taxes, how many hours did it take to clean the house? So what we can do is set up an equation where we say y is a final amount before taxes. Y is the final amount before taxes. And we can say that x equals the number of hours. Okay, and using what we just built, we can say that our final amount before taxes, or y, is going to equal how many hours, or this amount of hours tells us that that's we're going to be a variable per hour. So we can say 32.50 per hour, or the amount of hours that it's going to take, we're going to multiply it by that to get that amount of hours. Then no matter what, if they're there for 30 minutes, an hour, 50 hours, they're going to charge $20 flat. So we have to add that into the amount before taxes. Okay, so we've built an equation from this practical everyday problem. Okay, now we have to see how many hours we have our service there for if we are billed for $117.50 before taxes. So I'm going to change colors, and actually the amount before taxes will be $117.50. And for our purposes, we're solving for x, or the amount of hours we were there. So if we start using our rules to solve equations, we can subtract 20 on both sides to do the inverse operation. So what are we going to have? Well, 1750 minus 20 is 97.50 equals 32.50x. So to get x by it, so we have to divide 32.50 on both sides of the equation. And when we do that, you're going to see that this fraction is equal to 3. So that means that the housekeepers were there for 3 hours. And that is how you solve a problem that looks like that. It took 3 hours. Okay, and if we keep looking, we see example 2, which involves a veterinarian who wants to build a fence in a large rectangular region in the yard behind her office for exercising dogs that are boarded overnight. She has 130 feet of fencing to use for the perimeter of the region. What should the dimensions of the region be if she wants a length of 15 feet greater than the width? Okay, so first we need some basic knowledge. What is the formula for the perimeter of a rectangle? Well, formula for perimeter of rectangle. Well, that's going to look like P equals 2L plus 2W, where L is the length and W is the width. Okay, and we're given some knowledge here that we want the length to be 15 feet greater than the width. So what that means is that she wants the length to be 15 greater than the width. That's what this statement underlined in blue means. So what we can do now is plug 15 plus W, or what the length is equal to, we want the desired length to be, in for L, and solve what the perimeter will be. So we're going to take this piece of knowledge and plug it in for L. So we'll have P equals 2, and then for that L that was there, we're going to put 15 plus W, and then we'll just write the 2W. Now we want to use our rules to solve for W. And we also can plug in for P. That's going to be the total amount of fence. So we have 130. Let's plug 130 in for P. And just rewrite this formula we have. Okay, now let's use the rules of the distributive property to take this 2 and multiply it by everything inside that set of parentheses. So 130 equals 2 times 15 plus 2 times the W inside the parentheses plus 2W. That's a weird looking W. That's better. Okay, so let's go through and simplify. 2 times 15 is 30, plus 2 times W is just 2W, plus 2W. Okay, so 130 equals 30, and I want to bring the two W's together. So 2W plus 2W is just 4W. Now let's work by getting the W's by itself. So we'll start by subtracting the 30 because we have to work away from the variable in the beginning. So 130 minus 30 is 100 equals 4W. Finally, now to get W by itself, we do the opposite. That's what's happening. So 4 multiplied by W is 4W. So to get W by itself, use the division property, divide by 4 on both sides. 4 will cancel out. So 100 divided by 4 is 25 equals W. So the width should be 25, and the length should be, should write feet right there. Okay, and if we look back, we wanted the length to be L equals 15 plus W. Well, now that we know what W is, we can say 15 plus the value for W, which is 25. And if we add those together, you're going to get 40. So the length should be 40 feet. And that should be the dimension of the fence. And finally, if we look at example 3, this is actually a very good problem, and it makes you think. So it says the relationship between Fahrenheit temperature and Celsius temperature is shown by the formula F equals 9/5 C plus 23. At what temperature will a Fahrenheit thermometer read the same as a Celsius thermometer? Now, some physicists and mathematicians may be able to memorize that fact on top of their heads, but for those that can't, there is this great method to do it. So I like to start off by writing F, which denotes Fahrenheit, equals 9/5, C, which denotes the Celsius temperature, plus 32. Okay, now you may be saying, well, I could use graphing, but I'd need one more equation to see where the two lines intersect, and that would be the temperature where they are the same. That'd be one way to do it, but we're only given one equation. And it looks like it's an equation written in two variable form, but actually it's written in one variable form. All you need to do is replace this C with an F and bring the F's together and solve. So if we just do that one simple thing, we say F equals 9/5, and replace that C with an F, since we're solving for Fahrenheit, and plus 32, let's just bring these 32's together and solve for F. Excuse me, let's bring these F's together and solve for the F. And we should get what the temperature should be when the two meet. So to do that, what you want to do is subtract 9/5 F on both sides of the equation. And when you do that, you can remember that a fraction, there was just like a coefficient of 1 in front of that F right there. So you can rewrite that as 5/5 because that fraction will reduce to 1. And now since you have common denominators, you may now use subtraction. So we have 5 minus 9. That's going to leave you with a minus 4. And then we do not forget our denominator, which is 5. Place our F right there, equals 32, because we have not done anything with 32 yet. Okay, now to get that F by itself, we can multiply by the inverse, or the reciprocal, or a negative 5/4 on both sides of the equation. And when we do that, we're going to get a positive F equals 32 times the fraction negative 5/4. That's going to reduce to negative 40. So that means Fahrenheit and Celsius read the same at only negative 40 degrees. And you can check Google or textbooks, however you want, and you can see that negative 40 will reach the both for Fahrenheit and Celsius. So this is a very practical math problem, and these are just some examples of some things you may see in homework or exams.